You have already tried out the use of virtual machines and virtual environments such as Anaconda to create repeatable environments. Virtual machines offer great flexibility and allow running different operating systems at the cost of significant overhead for memory and disk space, as you have to keep the whole operating system installed and running in parallel to your host system. Also, you have to allocate memory in advance, and you cannot change the memory available to virtual machine as you go, so any free space inside the virtual machine itself is in principle wasted. Virtual environments, on the other hand, require a minimal amount of extra space and have no other overheads, for example, no memory overhead, but you are limited to the packages and features available to your host operating system, and you cannot, for example, install additional software such as MySQL Server only for a specific environment. So it is difficult to choose which mechanism you want to use. However, there is also an in-between solution for the case where neither virtual machine nor virtual environment fit quite well. These are called containers. Containers provide isolation between applications not only at a memory level, but also on file system and hardware or device level. In simpler terms, each container runs within its own virtual file system that prevents access to external files and presents paths in such a way that the application still thinks that it is executed in a real environment where no other application exists. Besides that, however, all calls from applications to operating system are handled directly by the host operating system kernel, with no overhead. Also, access to devices such as network interfaces is prevented by default and requires specifically allowing certain containers to access certain devices. Usually containers have no access to hardware anyway, and all communication occurs over virtual network interfaces that container management suite creates for such container. These interfaces are also implementing only the logic of moving network packets around and do not emulate hardware behavior, so they have very low overhead as well. One of the most popular containerization solution is called Containerd, which provides the core functionality and Docker that is used to create, manage, and run Containerd containers. So, what do we need to make a container? In essence, the only mandatory part is so-called container image. The image is a snapshot of the virtual file system that will be available inside the container. Most of the currently used containers are based on the core set of files produced by different GNU/Linux distributions such as Debian and Alpine. Here, the GNU/ part plays a crucial role because those base images do not include any Linux kernel of their own. Instead, they ship the minimal set of precompiled tools that is necessary to install other software such as apt and apk package managers, and also standard utilities from GNU operating system. The only reason why we consider those Linux distributions is because the software is compiled into ELF binary format, which is used in Linux operating systems, and because those tools are designed to use Linux kernel API provided by the host operating system. And this leads us to the biggest drawback of using containers, which is you have to use Linux as host operating system to run Docker. Fortunately, for most applications of Docker, that is not a problem, because most of the servers that are primary users of Docker and containerization technology are run using Linux anyway. Other than that, images are built in so-called layers. Every layer is represented by the so-called delta of changes that includes list of new or modified files with the new contents and lists of old files that were removed. So every layer is built on top of the previous that is considered to be its base. For example, we can perform an operation that installs some application or library into container. That operation will take base image, create a container from it, execute installation command in that container, and then it will take the resulting file system and produce a delta between new image and the old image, and it will store this delta information. To run the produced application, Docker will locate both the base image and all deltas that apply, and apply them in correct order to create the actual image of the container. And then it launches that image as container and runs the requested application in it. This makes execution of applications exceptionally repeatable, as you also reset file system every time the container is recreated from the image. The files that need to be preserved between restarts, such as database contents, are stored in specifically marked folders that are mapped to host file system or onto so-called volumes that persist between container recreation. Let's have a look how you can install Docker and Docker Compose in different environments. Installation of Docker in Ubuntu is very simple and straightforward. In order to install Docker and Docker Compose in Ubuntu, you just need to open Terminal. If you forget, then you press Show Applications and select Terminal, or type TER in search to find it out. And then in the terminal, you need to type sudo, sudo, space, apt, space, install, space, docker, space, docker-compose, and press enter. And then you need to type yes when you are presented with prompt asking whether you want to install Docker and Docker Compose and the supporting packages. Once the installation is done, you should be able to access Docker by typing Docker, and you will see this help prompt, and you should be able to do some simple test. For example, you should be able to pull an image of Python using the latest tag. In case of such error message, you can try adding your user into the Docker group first, but if this does not help, you just need to use Docker as administrator. So you just type sudo in front of every Docker command. And as you can see, this command started successfully downloading the Python image from official Docker Cloud repository. And once it's done, you will be able to run this Python image on your machine locally as container. Another part that you want to check is presence of Docker Compose. You type in the console docker-compose, and it should present you this help prompt. We will discuss the syntax of working with Docker Compose and Compose files later. In order to use Docker under Windows, you will need to do several things. First, you will need to download PuTTY terminal client to be able to log in into a remote machine via secure shell. You can get either full installer or a portable version from puttygen.com, download PuTTY, and I will just download PuTTY for Windows here, and I will use the 64-bit installer for version 0.76. Once the file is downloaded, you just need to run it and follow the installation guide. You can use all defaults here and just install it and press finish. Now the second part is you need to add VirtualBox image that I have prepared for you that already has Docker installed into your VirtualBox. You can download the image from Moodle using this link, minimal Docker VM for VirtualBox, and it will redirect you to OneDrive folder. And there you need to click on the download button in the upper left side of the screen. Once you click it, the download will start. The file is 633 megabytes. You can install VirtualBox itself following the guides that I have presented in the lectures 1 and 2. And once this file is downloaded, you just need to open it in folder by clicking the button show in folder. And then you need to extract this archive by right-clicking and pressing extract all. And let's put it into minimal Docker folder. And now you need to right-click this folder, select cut, because we're going to move it, and go into your disk C or system disk, users, your username, and then you need to go to VirtualBox space VMs and press right click on the empty space and select paste. Now you need to ensure that you have restarted your VirtualBox manager, and in this screen you select machine, add, and then you will see these folders, and you need to go into your minimal Docker folder and select the VirtualBox file. And now it has been added successfully, but I will not be able to start it. As you can see, for me it shows that I don't have available Hyper-V. To continue with this, I will switch back to my main operating system. So we're back in the main operating system, and I have already extracted minimal Docker files into VirtualBox VMs folder in my user folder here. So all I need to do is go to machine, add, select this minimal Docker and minimal Docker VBox, and it appears right away here in the list. What you need to do after that is you need to click settings, and you need to modify network settings for the first NAT interface, and you need to enable port forwarding. You need to make sure that your port forwarding is configured as follows, so that you forward your port 2222 on your host to guest port 22. This is a port that is necessary for using a secure shell or SSH. And when this is ready, you can press start and you can see the machine booting here. You don't need to press anything and you don't need to use this console. It will start itself automatically. Instead, we are going to open PuTTY. And when you open PuTTY, you will be presented with this screen. And to access the virtual machine terminal, you will need to type 127.0.0.1. This is your local IP address, always. And you will need to change port to 2222. And when you see this prompt, this means that virtual machine have booted successfully. You can start by opening connection. Another thing that you need to add here is user at 127.0.0.1. This is necessary to specify username when you are connected. And you can save this session, for example, as Docker VM. And next time you will be able to just select this and press load to restore the settings. And open. And you will get this kind of alert. This alerts you that the host you are connecting to is unknown and you are connecting to it for the first time. And it provides you with its fingerprint. If you know how asynchronous encryption works, you can verify these fingerprints. But other than that, since we are trusting this host to be what it is, we can just accept it. And we are now in the prompt here in the upper left. You can see welcome message, and it asks for password for user. And the default password is password, just English word password like this. And once you enter it, you will end up in the prompt. Let's close it for the moment and review how we can make this screen larger. So we select Docker VM, load, and then we go to window fonts and select change. And then we can increase the size, for example, by selecting Liberation Mono and increasing the size of the font. And I will save the settings again by pressing the save button and open it. And as you can see, now the font is much larger. Okay, so in this machine, we already have Docker pre-installed, and you don't need to type sudo to access either Docker or Docker Compose. So you can use them right away. And we can try pulling the same Python image that we did in the Ubuntu machine. This image is based on latest Debian, so you can use this as proper operating system if you want to. And you can use apt to install different packages, whatever you need. But for the time being, we are going to use it only to create Docker images and Docker containers. And the password for sudo is exactly the same as what you have by default, password. And you are recommended to change it by typing PASSWD. This is a utility that will allow you to select new password. And if you type your current password after that, then you will be able to enter new one. I will continue this example using Docker virtual machine and PuTTY as SSH client, because I think this would be the most universal solution for most of the students. But you can also follow the same commands using just Ubuntu, because Debian and Ubuntu are very similar and there should be no major difference in how you run these commands. One step that we need to implement first before continuing, and this is specific for virtual machine Docker implementation, so if you already have virtual machine Ubuntu, you don't need to do that, is adding the shared folder. So I will create a new shared folder and I will select my code folder with my projects, just as we did in the first lecture for Ubuntu, and I will enable auto mount feature, and I will not specify any mount point for this. And I will select OK. OK. And let's see if we have this file mounted. To do that, we type command mount and see if we have the mounted folder. Yes, now we have code mounted on /media/sfcode. In order to access files from this shared folder, which are not owned by you, you can use superuser rights, and we can first enter superuser bash terminal by typing sudo space bash, and now you can see this hash symbol instead of $sign, which indicates that we are running commands as root, and you should not do any long operations from root. So what we're going to do, we're going to just change our directory to media sf code, and then we're going to copy the necessary files into our virtual machine, and we're going to use -r flag to copy them recursively, and we're going to copy them into a user folder, and we're going to exit this. So now we can change to home user, and we will need to run sudo chown -r user to set ownership of the files here, and we're going to supply this i2cs folder, and this command changes ownership of all files within this i2cs folder to our username. Now we have some files that we can use, so let's go and make our first Docker file. First, we will make a directory for a Docker application, and we will change our directory there. Then we will copy one of the files. For example, we can copy imp.py file here. This dot indicates that we want to copy it into the current directory. And we can use cat to preview what's the content of this file. As you can see, it's rather simple. It is probably not the best application for Dockerization because it requires user interaction, but as an example, we will use this one. And now we need to create a Docker file. To do that, we can use either touch command and then use whatever editor we prefer, or we can directly use, for example, nano editor and type the new Docker file name right after that. So this is the file name that we want to create. And nano is part of this Debian installation. And if it is not, you can use sudo space apt space install space nano to install this command. So first line of a Docker file should be the indication from which base image we want this Docker file to be created. In this case, we want to create it from Python latest because we would like to have Python already pre-installed. You can look up different base Docker images on the Docker help. Then, as a second command, we would like to copy our input.py into some folder inside our image. Let's name that folder app, and let's put input.py using its own name, like this. We need two more things. So first we need to specify the working directory using workdir command, and we would like to run our code while we are being in the /app directory. And then the last command, cmd, specifies which actual binary we would like to execute and which arguments we would like to pass to it. So in this case, we want to be in the folder /app, and we want to run python inp.py. And this is enough to create the minimal Docker file to run a Python application. Now, if we run docker build and specify dot or current folder as the source of Docker file, you can see that docker build command successfully pulled the Python latest image. It actually used the version that we have already downloaded before. Then it copied input.py into this location. It changed our working dir location. And finally, it set up the property of that container so that when we run this container, it will be executing Python binary with input.py as an argument. Now to start this, we are going to use this hash because this is the hash that is the result of our last execution step. And this is effectively the technical name of our image. So if we are going to type docker run and paste the hash that we have created, we can actually type it manually and we don't need to specify it in full. A few first letters would be enough. As you can see, it tries to run it and it gets into an error because it fails to get any user input because our system is not connecting to the application in terminal mode. To have terminal interaction, we add this TI flag. And now we can run our input program that will do the calculations inside this Docker container. And once it's done, we just type yes and exit it normally. These numbers, the hash numbers for images, can be used, but they are not very useful and not very convenient to use. So what we are going to do, we are going to also add tagging command. In this case, we're going to tag our containers that we have built with my container and then 0.01. And as you can see, now it has created a tag for the same image, the same hash, and it created this my container. Now, instead of using the hash name, we can actually type here my container and the tagged version, and it will result in the same execution. Okay, now let's make some applications that doesn't require user input. So first of all, we are going to modify our input.py file, and we're actually going to cut it away completely and do some simple hello world application, and we'll type hello docker, and we are going to use input arguments. To use input arguments for your command, you need to import sys, and then you can actually access the values from the input arguments as sys.argv. Sys.argv is a list that contains all the strings that have been passed to the script as arguments in command line, and you will see what it means in a moment. So now we have modified this input.py file. We can rebuild our container. We will assign a different version to it. And as you can see now, it has used cached version from Python, and then everything else has been recreated because we have changed the input.py file. And if we run this, we now have properly running my container version 0.02. And if we use 0.01 version, we will still have the old version of our application. You can see that this script has printed out hello docker, and it also printed out this list. And the first argument in argv is the name of the file that has been executed. However, if we are going to modify our Dockerfile script, and add some argument here, for example, and rebuild it as version 3, now we can run version 3. And as you can see, these two arguments have been successfully passed into our command. And actually at this time, we no longer need this TI because we don't need this application to be interactive. Finally, we can also run different commands. So after the name of the image, we can actually specify a custom command name. Let's do the same and type python space input.py. And as you can see, it executed correctly, although in previous version, it has also added additional arguments here. But we can add more arguments of our own after this command, and it will present them as list correctly. And this is what Boeing to Docker will be using in the future, and we will discuss this a bit later. Okay, one last step that is necessary for us to use these images in our distributed computation is the ability to share these images with other people. Docker provides a service of hosting publicly available open source images. So long as you are doing this for non-commercial purpose and you are not having any private material that you cannot share publicly, you can actually use Docker repository. And to access that, you need to register on Docker Hub. This is hub.docker.com, and I will log out. So you can press sign up button, and then you will be prompted to create Docker ID that you can later use. And you need to create this user ID so that you can store images in the Docker Hub. I already have one, so I can just use my Docker ID name and the password that I have specified. And as you can see, I have one image stored here that has been set to public. And at the moment, I will just use the same repository to push the results of our computation. So here it suggests that if you want to store your image, you need to use this command in Docker. We go to Docker and we type push, and then it is your username / the name of the Docker Hub repository. In this case, this is my test Boeing calculation, and I will be using version 0.03 as a tag name for that. And as you can see, now we have an error message that we don't have image with this tag. So when we are building this container, we need to modify our tagging command. As you can see, we can just add username and the proper name of the image to the tag, and we have now tagged the version of our image, and now we can try pushing it. And everything went well until we have been checked for the access. And here we see that the access was denied. And this is because I have not logged in. To do that, you need to use docker login command. And you just type your username and whatever password you have specified in your Docker account. And once you have entered them correctly, you will see this login succeeded message, and you will be able to push the container